This is Savankat. Now I would like to explain my recent task, that is sentiment analyzer using DistilBERT model. This is a production ready sentiment analysis system built using DistilBERT fine-tuned on the IMDb dataset. The model is served using fast API, visualized using Streamlit, and fully containerized with Docker Compose. Now I explain problem statement. In real world, companies receive large volume of customer feedback and social media comments. Manually analyzing sentiment is inefficient. This project automates sentiment classification using a fine-tuned transformer model. For example, Twitter, Amazon, Netflix. Now explain why I choose DistilBERT model. Because of DistilBERT model is 40% smaller and 60% faster than BRT, bed and row bed and other models. This makes it ideal for production APIs where latency and memory usage matters. I have used a dataset as IMDb for movie reviews because of it is a standard benchmark dataset for sentiment classification. Now I would like to explain our architecture overview. This is the architecture overview. First of all, it has three layers. One is Streamlit UI port run on port 8501. Second one is Fast API backend port run on running port is 8000. Third is DistilBERT model inside API container workflow. Users send a request by the Streamlit UI. It receives to Fast API backend. Then it receives to tokenizer. Then it receives to model and then model training. I have implemented three steps approaches three. That means it trained end to end three times for improve the accuracy and F1 score battle performance of the model. After the training the model, it predict and return the result to the UI. Now I would like to explain pipeline. This is the pipeline has main two steps. One is pre-process the data. This is the pre-process file. That means it removes the letters. It removes the not means letter. It removes the numbers, converts the lowercase, remove the punctuations, remove the symbols, cleaning. Then after cleaning the process is completed, it divide the entire test into train.csv and test.csv. Save CSV files in data preprocessed model. After the second step is train.pv. In this file, load the DistilBERT model. I will show you. This is load the DistilBERT model and tokenize the dataset. Save the model by store the matrix in JS1. Output of this file is model output folder matrix.json run summary.json. I have implemented fast API for backend API's responses. I have implemented Streamlit UI for user interface because of it is a framework and it supports graphs and charts when compared to Gradio. That's why I prefer Stream.ui. It is also implemented by using Gradio, but Stream.ui it automatically converts Python script to web UI. It also supports graphs, charts very easily when compared to Gradio. Then containerize my full application in Docker. This is the docker.api. It starts and has to download the required.txt files and API test files. After that, it starts by using these files entry pointed api.sh. This is the starting file for containers. This is the UI Docker file. In that, download the requirement.ui.txt. After that, it starts by using the command streamlit run. This is the command. I have orchestrated my two Docker files in Docker Compose file. I have implemented batch size is 5 and sample size is 250 because of just for demo, but not good for production ready. It supports because of my out of memory issues is occurred. That's why I changed the batch size to 5, but it's not for production level, but it's sufficient for demos. While implementing, I have faced the challenges that is model loading delay inside the Docker, managing large model size, memory optimization during the training, handling input validation, ensuring container health readiness. These are the challenges I have faced during the implementation of my project. Improvements in future: add Redis caching for repeated queries, add GPU support, deploy on AWS EC2, add rate limiting. This is the rate limiting. I have add 2e minus 5, add another rate limiting for best approach, add CI/CD pipeline. These are the future improvements. Now I will show a practical demo of my task. First of all, you need to run Docker engine in your desktop. I have already run. After that, you have to enter the command docker -compose up -build. It automatically installs the requirements.txt files, and it automatically pre-processes the entire data and split into train.csv and test.csv. After that, train the model within 3 steps. Approach, I will give approach 3. That means it repeats the 3 times from end to end for better accuracy and F1 score. After that, it start on port 8501. It can run access on Chrome. This is the UI interface. Now I will give you one tweet. I will give about the movie Postma movie. Absolute mass entertainer analyze sentiment. It gives the result negative because of absolute. If suppose gives good, it shows sentiment like positive because of good. It shows confidence 50.6% because of I have tested against the only few samples, 250 samples, and batch size is 5. That's why it shows less confidence. If you test against the samples 2000, 5000 like that, it shows the confidence 97% like that. For just for demo purpose, I will use a small amount of samples. If you give a mixed tweet like this, is good movie, but not perfect. Its accuracy is not accurate because of I have already told you this is not trained for a large amount of samples because of it for just for demo purpose and for starting the container. That's why I changed the samples to less amount. Okay, it shows history whatever you give and charts and conference overtime bar graph and download history if you want. And model performance also analyzes accuracy 70%, precision 100%, recall F1 score. This is the bar chart. Training versus validation loss, accuracy. Next, training hyperparameters. That means model name, landing rate, batch size, approach. How much time it takes to start. That's also shown. This is the sidebar. That's it about my project. Thank you.